So today's premise is very simple. Yesterday, we looked at terms and variables. We looked at how we could add or subtract variables. Why? So, try to, slow, split the phone away, okay? If you can add or subtract terms, it's essentially because those terms are numbers, we just don't know what they are. If we can add or subtract terms, we should also be able to add or subtract or multiply or divide numbers. That's the bottom line. So today I'm introducing something called a distributive property. And it's going to introduce how we will deal with multiplication. And of course, not necessarily division, we'll take it one step at a time. Okay? Question, Abby? Well, terms are just, it's a product of a letter and a number, a variable and a coefficient. So this right here will be a term, 3x. The 6 would be a term, right? So recapping what we talked about yesterday. So as a starter, okay, I'll say this. Terms are numbers too, right? If we can add subterms, we should also be able to multiply, divide terms. That's my premise for today. So the question is this, okay? Here's an example. You don't have to write this down, but I want you to understand this. If I said 3 times 3, what's the answer? 9. But just because we have the two numbers and we multiply doesn't mean we can't do something like this. What if x was a 1? It would be 1 plus 2 times 3, right? It would be a 9 if x equals a 1. What if x equals a 2? What if x equals a 3? What if x equals a 4? So on and so forth. You still should be able to solve this without any mathematical errors, right? And so what happens when you are given something like this? How can we rearrange it? How can we simplify it? So on and so forth. That's today's lesson. Distributive property. So what happens when you have a number in front of a polynomial of two terms? Well, we'll get there. Polynomial with two terms. Polynomial with two terms. Oh, come on. Yes? A binomial. What do you do when you have a number multiplying to an entire binomial? How can we simplify it? Here we go. For each of the following examples, expand. Here's a new word, okay? So today's key idea is this distributive property. Let's expand. To use the distributive property, you need to multiply everything inside the bracket by the term, directly outside. Examples. If I have a number in front of x times 1, 2 is multiplying to everything inside. If I have a term in front of x plus y plus 1, the 2 multiplies with everything on the inside. It gets a term hanging out with every single thing on the inside, every single term of that polynomial. That's it. Here it is in action. 5 is multiplying with a binomial. That is 5 times x and 5 times 2. Done. We've done this before. We never really had a lesson on it. But again, this would have been an expectation from middle school, but we're going to look at it as if everything's fresh to everyone. Okay? Get a piece of paper out, right? Grab the paper. By now, this should be routine. Grab a pencil. I don't need to tell you this anymore. Let's keep going. -4 multiplying with the 2y, and -4 multiplying with a 5. You want to copy these arrows down? You can. But again, I want to get you to a point where you're so sick and tired of this that all of this is not going to be written. You go straight to the answer. Notice how I am not writing 5 times 2 equals 10. Oh, okay, it's a 10. I'm not writing that. You don't need to. Showing me this as the next line tells me you know exactly what you're doing. Anything more than this is extra. And if your teacher told you to show them 2 times 5 and underneath, that is incorrect. That is not showing of work. Please don't do that. Okay? Do not do that. You are welcome to do it in scrap paper somewhere else, but the next line should always be equal to the previous line. Here we go. -4 times 2, -8y, -4 times +5, -20. Done. This is proper showing of work. None of this. Some people might still do this, like -2, do this. They'll be like, okay, -4 times 2y equals -8y equals -4 times 5 equals -20. So therefore it's -8 minus. This is so wrong. I can't wrap my head around it. Please don't do this. This is not correct. Yes. Where is it? You're talking about here or here? Oh, yeah, the number is already a negative, so you're multiplying a negative with a positive and a negative with a positive. They both end up becoming negative. Okay, and so please don't do what I just did. Okay, and if you don't like the arrows because you're comfortable doing it in your head, -5 times the coefficient 4, that's a -20 with m. -5 times a -3, that's a +15. Done. No more, no less. I'm not going to insult your intelligence. If you don't show me any work of this and you write -20, I know what's going through your head. It's correct. Okay? You don't even need to show me scrap. You will see as you get more and more into the mathematics of when it is appropriate to show the work because it's very complicated versus just even being able to plug into the calculator. It's just very straightforward. Last one. Here's the example. Instead of a binomial, I have a trinomial. But the rule doesn't change. The 2, the term in front, that's multiplying, gets a chance with every single term in the trinomial. 2 times 5, those are the coefficients, 10 a squared. Please notice that the exponent does not change. That should make sense to you if you were practicing yesterday and thinking about it with the algebra tiles. 2 times -7, -14, 2 times 2, +4. Done. We're just about halfway done because this is going to be the bread and butter. Yes. What do you mean by, yeah? The rule changes no. And this is not even a rule because you already understand this. If I wrote 2 times, let me give you an example, okay? 2 times 5 is what? 10, okay. Is this wrong? 2 times 2 plus 3. Did I write anything different from the top line and the bottom line? They're all the same, right? Okay, now, what does this tell you? Go for it. 2 times 2 is, and that's why, right? So it's not that it's necessarily a rule I want you to memorize. It's just there's a logical explanation behind it. You can even use an example like this to prove yourself. Okay? It's just whatever's on the inside of the bracket is multiplied by that term on the outside. Okay, no matter what. And even if that number is a 1, you can technically still do it. So let's go. Remember, variables are still terms. If I can multiply a number into the bracket, you should also be able to multiply an x into the bracket, because an x is still a number. How does that work? Well, this is where exponent laws come in. Ugh. Remember from yesterday, x plus x is 2x. But if we are multiplying the same variables, we are using, exponents. We have x plus x plus x plus x, right? That would be 4x. But if you have x times x times x times x, we say we're multiplying 4 times, that's x to the power of 4. Very, very different. Okay, so when x is the term in front, like Miles was saying, the rule does not change. We are still multiplying, except in this case, we have an x multiplying with itself. So we write it as x squared. That's all. Okay. As an extra, you see that the term can sometimes be a full variable with a coefficient. So I'm going to write a little something here to remind you in case you forget. Multiply coefficient with coefficient, multiply variable with variable. What I mean, you'll see what I mean when I get there. Here we go. X is multiplying with every single term inside the bracket. And you can argue if there's no number in front, that's actually a 1x. I hope you'll agree with me. 1 times 2, 2. X times x, x squared. This is what I mean, multiply coefficient with coefficient, multiply variable with variable. It might be a good sort of mantra to keep so that you don't confuse yourself. Bless you. And then 1 times a positive 3, and x, well, x is all alone, so just x. Done. Again, no more, no less. That's all you have to show me to show that you understand distributive property. Okay. Same thing here. Let's do it. The term in front multiplies with every term inside the bracket. 2 times 3, and then x is just on its own. 2 times a negative 5, x times x. That's it. If you want it to be a keener, if you want to go the extra mile, proper mathematical convention states that the larger exponent or the larger degree should be first. So I am happy with that. I am okay with that. This is proper mathematical convention. Yes? In grade 10, you will. Like, it's what we call communication marks. If you've been paying attention to your assignments, on the very bottom of your assignment, there's this little chart that says communication 0.51, 1.52 marks. I'm not sure if you noticed that in your ratio thing, but look where David is on the very last page where it's dangling off the wall. If everyone wants to turn around, on the very last page that's dangling on the bottom of that corkboard, you'll see a little rectangle on the very bottom of that page, right? If you look carefully, every single one of my evaluations will have that, which rates your communication skills. As you get to grade 11 and grade 12, this is going to be a given. So I'm going to encourage you to try to remember to do this every single time. Okay? Any questions? No? All right. All right, we're making pretty good time. I am going to continue on the back page. Now we're looking at, okay, now that we know how to deal with brackets, distributive property, what can we do to go further? How much more complicated will the question be? How do you simplify it? Blah, 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 blah. Let's go to the next page. These bottom examples you can probably do on your own. I know it's a little harder, but you can check the answer key after. What do we do when we've got polynomials in brackets and they are adding? For example, here is an x plus 3 and it's adding to a 4x minus 5. The brackets might throw you off, but remember, if there's no number in front of the bracket, it actually means that there is a 1, just like here. And so, why not multiply that 1, expand this binomial, get rid of the brackets, and look what happens. It's right here. Okay, we have 1 times x is x. 1 times 3 is 3. 1 times 4x is 4x. And 1 times -5 is -5. All of a sudden, the brackets are gone. And now you can do what we did last class, which is, what do we do? What do we call it? Sorry, carry on. Yeah. Grouping. Yes, thank you. Oh gosh, come on, people. Okay, grouping like terms. Even if you don't know, or even if you know how to do it, it's also important to know what it's called. X, 4x, 3, and the -5. We are going to group them together and we will get -5 minus 2. We are doing the same thing. Notice that even if the numbers look a little weird or have a negative inside, we're doing the same distributive property. 1 times x, x. 1 times 3, 3. -1 times 4, -4x. And -1 times negative, positive 5x. We're doing the same thing again and again. And we group like terms. Let's see it in action. More than me just talking, it's better that you see it in action. So we will do A, and then we will do C, and you can reproduce it later. 1 times 2p, 2p. 1 times -2, -2. 1 times 4p, 4p. 1 times a 7, that's a 7. Group like terms. Yes. 1 is assumed it's always going to be there if there's no number. Assume it's a 1 and you can get rid of the brackets without having to do much. It's just the same numbers again and again. So we have 2p, 4p, 6p, -2, +7, +5. This is proper showing of work. You don't have to do 2p plus 4p equals 6p. Okay, that equals -2 plus 7 equals 5. Okay, that equals 6p plus 5. That is not correct. Every line you write has to be equal to the previous line. That's why we have the equal sign. Okay, please don't do this. Let's do it again. That's a +1. That's a -1. 1 times 3x, 3x. 1 times -5, -5. -1 times 4, -4x. -1 times 2, -2. And then just group. Jeremy, feel free to move if there's no one in front of you. Okay. Honestly, I don't want you to struggle like with that. I got to figure out a thing. There it is. Yes. Positive 3x is grouped with a negative 4x. So you could think about that part as 3x minus 4x, which happens to be negative 1x. Okay. That's it. And so the actual lesson is done. But this is what I might apply as, I'll give you one more example before I sort of set you free, because that's all we need to do. Okay, so people who are sort of trying to get tired, trying to get sleepy, just one more. Okay, see if you can apply that. Yep.
Why is the negative?
This one?
Yeah.
Oh, the question itself had a negative. I'm subtracting that binomial. So you could pretend it would be a negative 1. Okay, so here we go. What if, I'm not even going to show you this example. What if I ask you to expand and simplify this? Instead of 1s, I have 3 and a negative 2. Can you do it? It's the same stuff. Go ahead and try. You need a sheet? I think it might be important that you have. I'll give you a minute. I cannot have one on because everyone has taken my pencils. Want a pen for now? Yes. Okay, give me a second while I pause this video. All right, so we've got, so your answer, at least the first line would be 3m minus 15 negative 4m squared plus 2m. So this is what we call the expanding portion. Now, since I've done expanding, I'm going to simplify, which is the same as saying group-like terms. Negative 4m is all alone. This becomes 5m. That becomes negative 15. So this is a simplify portion. Right? Just to draw your attention, the reason I got the 5m is because I have a positive 3 and a positive 2m like terms. They're being added. Any questions? Yep. Yeah, go quickly. My final little reach before I set you free is where would this come in? Where does variables and multiplication ever sort of merge? Well, the most interesting part of math for you at least probably involves things like money, probably involves things like sports, probably involves things like friends and your phone bill, maybe, I don't know. Right now, I only have a boring example for you, something that everyone can relate with because they've probably worked on it when they were younger. What is the expression, or what is the formula for the area of a rectangle from your elementary days? Real quick. Area, rectangle. Come on, you must remember it. Yeah. Base times height or? I know, I got it. Just really quick to do it. Just put your hand up next time, okay? In this particular case, my length is 4x. I'll do it as a variable. And my width is 3x minus 2. Instead of leaving like that, I want an expanded expression, a statement, a mathematical sentence for the area. So you do exactly what we've done before. I see a monomial term multiplying with a binomial. So if you want a simplified expression for the area, you multiply it through. 4 times 3 is 12. X times x squared. 4 times -2 is -8. X is not multiplied with anything else, it's just X. This is my statement, mathematical statement, an algebraic statement for the area. That's it. Now, clearly, it seems simple enough as long as you keep practicing, everything is going to be okay. And some of you are like, I know this, but this is easy. Please don't underestimate it. I'm going to take a look at much more complicated word style problems tomorrow to make sure that you are not going to confuse yourself with multiplying variables versus adding variables and terms and blah, 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 blah. Okay, please practice. Once again, tomorrow I will be checking your homework. If there are too many questions that you don't think you can finish in the next 45 minutes, because we've got a lot of time in class, do every other. If you go to the very last page, expanding number 1 has A to I. Why not do ADG? Just to get a sprinkle of every type of question out there. Okay, do ADG. Number 2, do like ACE. Number 3, do AC. Number 4, do ACC. If you can get a good mix of all the questions. That's my recommendation to you.